For our project research, we made four different concrete panels, and what we did is for these sample panels is we made four different forms, and they were 1 foot by 1 foot by 1.5 inches thick. And as you can see, we made four different samples, and so for our research process, we experimented with different types of concrete and different finishes on the concrete. For our first sample that we poured was a 4,000 psi concrete mix, and we determined that by a water to cement ratio. And as you can tell here, we left it at a smooth finish just to see really how smooth that we could get it. We know that oftentimes concrete is broomed or something to add a little texture to it, so people won't slip and fall. For our second one, we used also by a water to cement ratio, we used a pervious concrete. And so we just did that by adding large aggregate and the cement ratio, so there would be enough voids where water could still pass through it. For our third panel, we used a 3,000 psi water ratio that gave us a 3,000 psi concrete, and the finish that we chose was a very rough finish. We used larger aggregate than we did in pervious concrete, which gave us a very rough finish. And for our fourth panel, we experimented with with curving the edges, and we did this by just using a finishing tool, or actually a tool much like a finishing tool. It's just a thin piece of sheet metal. But during the curing process, about the time that we would cut our control joints, I got the tool and we finished the edges, and it gave it a curved finish.
Shaking it.
Whose porter cable?
Mine.
Did you have to get that for school?
First year. It's probably gonna count.
That's good enough?
Yeah. Maybe until we get the sides off.
Until the hose stop.
Oh.
Actually, did we?
We began by finding the volume of one of our panels and multiplying by the waste factor that we would use. By taking the volume of aggregate and the volume of cement paste that we would need, and the water-cement ratio of 0.4, we used the unit weight of water and the unit weight of the cement to change the water-cement ratio from weight to volume. Multiplying this into the volume of water and the volume of cement that we would need, we found how much weight of water and weight of cement that we would need for the final mix. And using the unit weight of the aggregate, we found the weight of aggregate that we would need for this mix to be made. By taking what we had found for our specific mix and volume, we converted this into how much we needed to make 1 cubic foot and also 1 cubic yard of this mix of concrete.